Have you ever heard someone say layer 1 or layer 2 and had no idea what they meant? These terms get thrown around all the time in crypto, but most people don't actually understand how blockchain layers work or why they matter. Let's fix that. Let's start with the foundation, layer 1. A layer 1 blockchain is the base layer, the main network where everything else is built. It's where transactions happen, where data gets recorded, and where the core rules of the system are enforced. Bitcoin is a layer 1. Ethereum is a layer 1. Solana, Avalanche, and Cardano, all layer 1s. Layer 1 handles three major responsibilities. First, it provides security, meaning the network is designed to prevent hacks, double spending, or manipulation. Second, it handles consensus, which is the process where the network agrees on which transactions are valid. And third, it provides settlement, which means finalizing transactions and recording them permanently on the blockchain. The problem with layer 1 is that they're doing everything all at once, and that creates a bottleneck. The more people use the network, the slower and more expensive it becomes. If you've ever tried to send Ethereum during a busy time, you've probably seen gas fees spike to $50 or even more. And if you've tried to use Bitcoin for small payments, you may have waited several minutes or even longer for confirmation. So while layer 1s are secure and decentralized, they don't always scale well, and that's where layer 2 comes in. So here's why we need layer 2 solutions. A layer 2 is a separate system built on top of a layer 1. Think of it like an extra lane added to a busy highway. It helps reduce congestion on the main road while still connecting back to it for final settlement. Layer 2s are designed to make blockchains faster, cheaper, and more scalable, all without sacrificing the security of the base layer. Here's how it works. Instead of every transaction being recorded directly on the main blockchain, a layer 2 processes them off-chain, bundles them together, and sends a summary back to layer 1. This thing keeps secure, but also way more efficient. Let's say you want to buy coffee using Bitcoin. On layer 1, that could take 10 minutes and cost a few bucks. But with a layer 2, like the Lightning Network, it's nearly instant and costs pennies. You still get Bitcoin security, just without the wait or high fees. The same goes for Ethereum. Using layer 1 can cost $30 just to mint an NFT. But with a layer 2, like Arbitrum, Optimism, or Base, the same action costs far less and happens much faster. Here's the key difference. Layer 1 coins like ETH and Bitcoin secure the entire network. Layer 2 tokens like Arbitrum or Optimism are used with their own ecosystems for things like governance, rewards, and user incentives. But they still rely on the layer 1 for security and finality. So layer 2 isn't just about speed, it's what makes crypto actually usable, affordable, fast, and ready for real-world adoption. Now that you know why layer 2s exist, let's talk about how they work. There are a few different types of layer 2 systems, and each has its own approach. One popular type is called a roll-up. Roll-ups process transactions in batches off-chain and roll them up into one summary that gets posted to layer 1. This is where the name comes from. There are two main kinds, optimistic roll-ups and zero-knowledge roll-ups. Optimistic roll-ups assume transactions are valid by default, but they give the network time to challenge and dispute any bad data. This makes them efficient and fast, but still secure. Arbitrum and Optimism are examples of this approach. When I'm actually buying or selling crypto, I actually use Optimism quite a bit. It's fast, the fees are super low compared to Ethereum mainnet, and I've never had an issue getting my transactions through quickly. What I like most is that I still get the security of Ethereum, but I'm not paying crazy gas fees every time I want to make a move. For someone like me who makes regular transactions, that savings adds up fast. Zero-knowledge rollups, on the other hand, use cryptographic proofs to instantly verify that a batch of transactions is valid. That means no need to wait for challenges or dispute periods. This approach is more complex, but also more secure and scalable in the long run. ZK Sync and Starknet are examples of zero-knowledge rollups. There are also sidechains, which are independent blockchains that connect back to layer 1. Polygon's proof of stake chain is a good example. It runs its own system, but uses Ethereum for final settlement and asset bridging. Each of these layer 2 models offer different trade-offs. Some are faster, some are cheaper, and some are more secure. But they're all working towards the same goal, making blockchain usable at scale. So now you might be wondering, if there's a layer 1 and a layer 2, is there a layer 3? The answer is yes. Well, kind of. Layer 3 isn't officially defined the same way, but it usually refers to application-specific systems that are built on top of layer 2s. In other words, if layer 2 is the fast lane, layer 3 is the exit ramp. A more specialized route that's designed for a specific use case, like gaming, social apps, or data indexing. One good example is the graph. It's a protocol that indexes blockchain data so apps can pull information more efficiently. Other layer 3s might focus on privacy, user experience, or developer tools, all while relying on layer 2 and layer 1 underneath for security. The idea is to break things down even further so that each layer handles what it's best at. Layer 1 keeps things safe, layer 2 handles speed and scale, and layer 3 adds more functionality, more customization, and better user experiences. So now that you've seen how all the layers work, let's talk about why it actually matters. Layering helps blockchains solve its biggest challenge, scaling. Right now, blockchains are too slow and too expensive for most people to use every day. But with multiple layers working together, we can keep the network secure while still making it fast, affordable, and easy to build on. It also helps bring in new users. With layer 2 solutions, you don't need to pay $30 just to swap a token or mint an NFT. With layer 3, you can use apps that feel more like Web 2, smooth, fast, and intuitive. For developers, it's a dream. Instead of trying to build everything on a single congested network, they can use different layers to build faster, more flexible applications. And for users like us, it means better products and lower costs. Think of it like this. The base layer gives us trust. The second layer gives us speed. And the third layer gives us personalization. Together, they create an entire stack, like the internet, that lets us do more with fewer limits. So that's it. Now you understand the blockchain stack. Layer 1 handles the base network and security, layer 2 makes it faster and cheaper, and layer 3 brings the apps and experiences to life. If this helped you finally make sense of blockchain layers, go ahead and hit like, subscribe, and drop a comment below. Thanks for watching, and I'll see you in the next one.